Out in the boundless ocean, where the water stretches for miles in every direction, and the horizon disappears into a blur of gray and blue, U.S. Navy ships battle forces far more intimidating than any enemy vessel, Mother Nature herself. Every single deployment carries with it a risk that can't be charted on a map or predicted with absolute certainty. With some 50,000 Navy sailors deployed at any given moment across roughly 100 ships, it becomes immediately clear just how vital preparation, resilience, and advanced design are for survival. These aren't leisurely cruises. These are floating cities, often with 60 to 90 aircraft aboard. Aircraft that can push the ship's value into the $10 billion range. One bad storm could mean catastrophic loss, both financially and in terms of human life. When the sea turns violent, it doesn't tap politely, it strikes hard. Wind speeds exceeding 60 knots, or nearly 70 miles per hour, churn the waters into towering waves that can reportedly rise as high as 300 feet. That's taller than the Statue of Liberty, waves with the power to crush steel and twist reinforced hulls. Conditions like these make it nearly impossible to maintain control of a vessel. Ships begin to pitch and roll aggressively, their paths thrown wildly off course. And when a ship loses stability, the situation escalates quickly. Heavy machinery on board becomes a threat itself, shifting dangerously with each roll of the ship. Injuries mount, equipment gets damaged, and the lives of thousands can hang in the balance. The stress on these ships is relentless. It's not just the external pressure from the sea, it's the internal strain of housing hundreds to thousands of crew members and high-tech systems in a structure that must remain operational through it all. The design must account for forces far beyond typical engineering tolerances, and yet it's impossible to plan for every situation. There's always the one storm, the one anomaly, that pushes everything past its breaking point. The tragedy of the SS El Faro on October 1st, 2015, stands as a somber reminder of that harsh reality. The cargo ship, with 33 souls aboard, sailed directly into the eye wall of Hurricane Joaquin. It vanished. No survivors. No wreckage definitively recovered. Despite extensive efforts, the ship remains a ghost beneath the waves. Since that harrowing event, the Navy has overhauled safety standards. Protocols have been tightened, and ship design has seen significant advancement, integrating cutting-edge weather forecasting and structural reinforcement. But out there, where the ocean has no master and the sky can turn without warning, no amount of preparation guarantees safety. These floating giants face enemies that don't yield, don't retreat, and don't negotiate. And every time a sailor steps aboard and looks out at that endless, restless expanse, they do so knowing the sea will always have the final word. But before we move further, don't forget to hit the like and subscribe button for more exciting stuff like this. Engineering and design. Balancing a massive naval warship in a raging ocean isn't far off from trying to steady a pencil on a fingertip during an earthquake. Yet somehow, U.S. Navy ships, some worth upwards of $10 billion and packed with aircraft, personnel, and heavy machinery, managed to ride out even the most brutal storms. Their ability to stay upright and operational through these punishing conditions isn't luck. It's physics, precision engineering, and decades of evolving naval design working in perfect harmony. At the core of this balancing act is a simple principle: density. Ships float because their average density is lower than that of water. Gravity pulls down, but the upward force from displaced water, buoyancy, wins. But floating is one thing. Staying stable in 60-knot winds and waves towering higher than a 25-story building is another challenge entirely. That's where the center of gravity becomes critical. U.S. Navy ships are carefully engineered to keep their center of gravity as low as possible. Heavy fuel tanks, massive engines, and essential equipment are placed deep in the lower decks. Every piece of gear, every new addition is calculated by onboard engineers to make sure it doesn't throw off this delicate equilibrium. The shape of the hull is another unsung hero. Most ships feature a wide U-shaped hull, designed to resist tipping and reduce the kind of side-to-side motion that can cripple smaller vessels. But aircraft carriers, towering and long, go with a more aggressive V-shape. This lets them slice through waves instead of being tossed by them. Still, when even that isn't enough, there's the ballast system, a clever mechanism that shifts water weight in the ship's tanks to adjust balance in real time. This system can raise or lower the ship's center of gravity, keeping it level no matter how the ocean rages beneath it. It's these often invisible systems, engineered into every bolt and beam, that keep thousands of lives safe and missions on course in one of the most hostile environments on Earth. Advanced technologies, out in waters where storms don't ask for permission and waves tower like skyscrapers, the U.S. Navy relies on more than just tradition and toughness to stay in the fight. Embedded deep in the heart of every modern warship are technologies specifically designed to keep these giants steady when the sea turns wild. Among the most effective are fin stabilizers, sleek, wing-like structures that emerge from a ship's hull and behave like the ailerons on a fighter jet. Their job? To fight back against the relentless rolling and pitching caused by waves. For a vessel trying to launch precision strikes or maintain radar lock in unstable conditions, these fins are mission critical. Without them, launching a missile or even operating sensitive equipment would be nearly impossible in rough seas. They transform a ship into a steady taut, lethal platform that doesn't flinch when the ocean does. But the innovation doesn't stop there. Gyroscopic stabilizers take the battle for balance into another dimension, literally. Housed in vacuum-sealed spheres, these systems use flywheels spinning at speeds up to 10,700 RPM to create torque that resists motion. The result is a counterforce that keeps the ship level as it's being rocked side to side. It's like riding a bike that won't tip over, no matter how hard the wind tries to push. And with computer-controlled systems constantly adjusting their angle, these gyros respond to changing conditions with precision, providing stabilization in ways traditional systems simply can't match. Even smaller vessels aren't left to chance. Enter self-righting technology, an innovation that might seem straight out of science fiction. These vessels are designed to flip themselves upright after capsizing. Using weighted keels, strategic hull angles, and smart ballast systems, they respond immediately once a tipping point is crossed. Onboard sensors and computer systems can activate water pumps to move ballast between tanks, aiding the natural righting process. For RHABs, rigid hull inflatable boats, this can mean the difference between surviving a rogue wave or being left stranded upside down in open water. With each layer of engineering and automated control, U.S. Navy ships are evolving into smarter, more survivable machines, capable of taking on the ocean's worst without sacrificing mission readiness or crew safety. These systems don't just keep ships upright, they keep them in the fight. Maintenance and inspection. Keeping a U.S. Navy warship mission-ready around the clock isn't just about having cutting-edge systems. It's about making sure every single part is running like clockwork. These ships face extreme conditions, and when the sea doesn't give second chances, there's zero room for oversight. That's why regular inspection and rigorous maintenance are built into the DNA of Navy operations. The smallest oversight, a misaligned sensor, a worn gasket, a corroded bolt, can spiral into a major hazard if left unchecked. Addressing these risks ahead of time is the job of an expert team made up of engineers, technicians, and highly trained sailors who do everything from scrubbing rust to upgrading software. Maintenance tasks are split into two primary categories: preventative and corrective. Preventative maintenance is the strategic defense against failure. Often referred to as a planned maintenance system, it includes tasks like lubricating moving parts, checking and adjusting fluid levels, running diagnostics, visual inspections, and vibration testing. The idea is to catch potential issues before they have a chance to develop into bigger problems. It's about keeping every valve, hinge, and circuit in its ideal working condition. Corrective maintenance, on the other hand, steps in when something has already gone wrong. Whether it's a hydraulic failure, a navigation glitch, or damage from rough seas, this form of maintenance focuses on repairing and restoring the ship's systems to full capacity. And when repairs are needed mid-mission, costs can spike rapidly, far exceeding routine upkeep. Then there's dry docking, a crucial process where ships are lifted out of the water into a special basin to access submerged parts like rudders, hulls, and propellers. Paired with overhaul maintenance, which involves breaking down and rebuilding key systems, these methods ensure even the most hidden parts of a ship are ready for the next storm. Every detail matters. Out at sea, the difference between smooth sailing and disaster can come down to a single unchecked component: weather forecasting. Out at sea, where the nearest help could be hundreds of miles away and conditions can turn violent with little warning, avoiding danger is often the best defense. That's why the U.S. Navy puts enormous focus on forecasting the weather, using some of the most advanced systems in the world to steer its ships clear of storms, typhoons, and unpredictable sea states. With lives, equipment, and multi-billion-dollar assets on the line, every forecast matters. Satellites lead the charge. Orbiting the Earth's poles, specialized meteorological satellites provide the Navy with high-resolution data on everything from cloud cover to water temperature, dust storms, and ice movement. This wide-angle view gives early insight into potential hazards forming across thousands of miles. It's a constant stream of intelligence beamed back to help ships decide where to sail, and more importantly, where not to. Complementing this are more than 1,000 weather buoys scattered across the globe. These devices float in key ocean regions, collecting localized data on wave height, wind speed, barometric pressure, and both air and sea temperatures. All of this feeds into systems that can track the early development of hurricanes or predict the weakening of storm systems, helping crews navigate safely through or around trouble. Sophisticated modeling tools are layered into the process. The Navy relies on powerful environmental models like those from the Joint Typhoon Warning Center and Wave Watch 3. These systems combine data from satellites, buoys, and shipboard sensors to simulate sea conditions with impressive accuracy. Every U.S. Navy ship also carries onboard weather instruments, such as anemometers, barometers, and advanced radar to monitor wind, pressure, and storm activity in real time. It's not only about dodging danger. These tools also help ships plan the most efficient routes, adjusting speed and heading to minimize fuel usage and avoid unnecessary strain on the vessel. A change in course by even a few degrees or a small reduction in speed can dramatically reduce the impact of rough seas. This technology isn't about reacting to weather, it's about staying ahead of it. Out in unpredictable waters, that edge can make all the difference between a smooth mission and a crisis. Crew training and safety procedures. Beneath every radar system, beneath the reinforced steel hull and billion-dollar engineering, beats the heart of every U.S. staff Navy vessel, the crew. Machines can track a storm or stabilize a ship, but it's the sailors who stand face-to-face with the chaos of the open sea and make decisions that shape outcomes in moments. And because the stakes are nothing short of survival, their training is as intense and unforgiving as the waters they sail. Every sailor is drilled to respond instinctively when things go wrong. One of the most critical drills is damage control. This isn't simply about fixing leaks, it's about acting in seconds when a flood threatens to destabilize the vessel. Teams are trained to identify and seal compartments, operate pumps, and maintain the ship's balance under extreme stress. It's the frontline defense against capsizing when time is measured in heartbeats. Then there's the evacuation drill, an organized exit plan for the unthinkable. When staying aboard is no longer an option, the crew must be ready to launch lifeboats, secure life jackets, and grab essential survival gear, all while the ship is being tossed by waves. Every movement is rehearsed, every second shaved off response times, because delays in those moments can cost lives. Man overboard drills bring another layer of urgency. The instant a sailor hits the water, the countdown begins. In rough seas, visibility drops fast, and cold temperatures take hold quicker than expected. The remaining crew must launch a search and recovery operation while battling the same conditions that caused the incident. All of these drills demand more than physical skill. They require unshakable coordination. Communication becomes lifeblood. Constant vigilance, 24/7 monitoring of the weather, and decisive action under pressure make up the rhythm of daily life aboard a Navy ship. The storm may rage, systems may strain, but it's the crew, calm, trained, and ready, that ultimately keeps the ship afloat. Modern advances and future improvements. Naval engineering is charging forward, reshaping the future of U.S. Navy vessels in ways that were once confined to speculation. One of the most promising advancements involves the shift toward lightweight composite materials. These are no ordinary replacements. They're designed to reduce the overall mass of a ship without sacrificing strength. That decrease in weight not only boosts fuel efficiency, but also improves stability and maneuverability, lowering the risk of capsizing, especially crucial during severe sea states. And since these materials are more resistant to corrosion, they also cut down on long-term maintenance costs. Meanwhile, the human element of naval operations is undergoing a transformation of its own. Virtual reality is now playing a central role in preparing crews for the most challenging scenarios. With VR simulations, sailors are placed into hyper-realistic environments where waves crash, winds howl, and systems fail, just like they might in a real-world emergency. These sessions sharpen decision-making under pressure, strengthen teamwork, and improve crisis response without the risks of live training. But the innovation doesn't stop there. Adaptive hull surfaces are now on the drawing board, structures that can actively respond to changing sea conditions. These hulls can shift shape based on speed and ocean turbulence, increasing hydrodynamic efficiency and fuel savings while boosting overall stability. It's a responsive design that aligns structure with environment in real time. Artificial intelligence is another leap forward. New AI-driven stability systems could read sensor data from across the ship, everything from wind speed to hull pressure, and make instant automated adjustments to stabilizers and ballast. These self-learning systems aim to stay one step ahead of the environment, not simply reacting to waves, but anticipating and neutralizing threats before they escalate. The idea is to create a ship that practically thinks for itself under duress. Together, these innovations hint at a future where naval vessels are more resilient, efficient, and intelligent than ever before. From smarter hulls to smarter crews, the direction is clear. Fewer vulnerabilities, tighter operations, and a better chance of staying afloat when nature hits with everything it's got. If you like this video, do let us know in the comments below, and don't forget to share it to others. Thanks for watching.